gozaimasu this morning. It's nice to see that everyone was able to make it at 10 o'clock. We start a little later this year. Our first talk this morning is in infrastructure we trust. You have like a quarter from Pawel Jakub Dawidek. Name I always screw up. Pawel's a developer in ZFS. He's a FreeBSD committer and has done a huge amount of work on file systems. And now he's going to tell us about GEOM.
No?
Yeah.
As George said, my name is Pawel Jakub Dawidek, and I would like to talk about GEOM. This talk basically sum up the work I did around GEOM. I actually didn't implement the GEOM itself. I was just working on various GEOM classes. So I would like to talk about them, about GEOM a bit, but I don't want to duplicate Paul Henning's talk about GEOM, so I will just concentrate on GEOM classes. Okay, so a bit of history. GEOM is in the FreeBSD CVS tree for like 6 years now. It was first committed to FreeBSD 5, and this is basically when we started to remove all the old hacks and integrate all the device drivers and file systems with GEOM. GEOM is basically a framework which handles all the storage we have, so all the disks, all the ND devices, all the partitions, mirror providers and stuff like that. The work was, GEOM was implemented by Paul Henning Camp, it was sponsored by DARPA, came as an infrastructure for GBDE. This is what Paul Henning Camp was sponsored for. When I read emails on FreeBSD mailing lists, many people confuse various words we use in GEOM. They sometimes call providers as consumers or as GEOMs. I will try to explain how it works. So first we have a class. GEOM class is basically a kernel module or something which we integrate compile in our kernel, and basically it provides particular transformation. For example, we have GEOM class that do partitions, we have GEOM class that does mirroring, that can encrypt data and stuff like that. Those are all separate GEOM classes. GEOM is basically, when you use lowercase, GEOM is basically an instance of a class. It's nothing you can touch or feel. It's basically only a virtual object we hang other stuff from, like providers and consumers. And we have provider, which is basically DFS entry. For example, /div/da0. This is basically what we can open, where we can read data from, when we can write data to. Okay, and we have consumers. Consumer is basically only a connection between GEOM from another class or from the same class to some provider from another class. So it's only a connection. It's nothing that appears in DFS. Okay, so this is how it looks in the kernel. We have, for example, GEOM class. Let's say it will be a GEOM disk, which only shows us a disk. And we have GEOMs inside this class, and we have provider that only hangs on those GEOMs. Maybe this will be a better example. Those are disks, and we only want to talk about providers. We have 3 disks in this class, and we can connect to them from another GEOM class. So you can see, you can assume that this class basically does, for example, mirroring. So it connects to 2 GEOM providers here and only 1 GEOM provider here. And we can stack all those classes as much as we want. But what you really want to remember are only providers and classes. You can, of course, know what is consumer, but it's only connection between providers. So it's not really important to remember the word. The important thing is what provider is. And provider is what appears in /d/dev. We can open GEOM providers, of course, for reading. We can open GEOM providers for writing, and also we can say that we want this provider to be opened exclusively, which means once we open provider exclusively, no one can open it for writing anymore. So basically, when we open provider for write, we also mark it exclusively, so we know that nobody will open it for write and, I know, mess our data. Before GEOM, it was possible to, for example, have a file system mounted and just override the data with DT utility or something like that. It's not possible with GEOM if you don't use any hacks. And this is basically, I think, very nice restriction. It actually saved me 1 disk already. So as you can see, this is XML output from the kernel with GEOM tree. And this is what we have for disk 80. This is how it is open. It have read count equal to 3, write count equal to 3, and exclusive count equal to 7. GEOM classes communicates using various I/O requests. So we have bio read and bio write requests, which are very obvious. Bio read is just ask for data, and bio write just send the data to another GEOM provider. But we also have bio delete, which can be used to free or destroy the data. For example, when we have a file system which removes some file and free some blocks, we can say bio delete to tell underlying provider that we don't need this data anymore. And if below us we have an encrypted provider like GLI, it will probably override the data with some random data. And for example, if we have like an empty device, it will just free the data. If it's memory backed empty device, it can just free the data. I'm not sure if any file system actually use bio delete, but I think Pawel Jakub is working on UFS to send bio delete when it's free the data. Okay, we have BioFlash. It was added when I was working on gjournal and ZFS. It basically tells underlying file system to flash write cache. When BioFlash returns, we should know that data is on stable storage. There is no caching between. Data should be on stable storage. We also have BioGetAdd I/O request, which basically can be used to ask for various properties of provider. Okay. basically how GEOM tree looks on my laptop. This is basically a really old hack. We have this C partition which shows entire slice or entire disk. So in the past we were able to write to the disk using this AD0S1C magic partition. Okay, so you can see that various GEOM classes have different colors, and I will start from the bottom. We have AD0, which is basically a disk in my laptop. I have one slice, AD0S1. Those are, of course, GEOM providers. Okay, I have one slice. I have 4 partitions. I didn't ask for that one, but those 3 are mine. So I have AD0S1, which I use for my root file system. And I have UFS file system on top of this GEOM provider. I use UFS/root label, so just looks nicer in mount output. I have swap partition, which I also have a name for, which is label/swap. I use glabel class for naming those providers. And my swap is encrypted using GLI. So my swap is encrypted. I have AD0S1 partition. This is used for ZFS file system. ZFS export one GEOM provider, which is zvault/tan/private, where I have encrypted UFS file system when I store where I store my private data. So even for a laptop, it's quite complex, but it really shows how how useful and flexible GEOM is. Okay, now I will try to enumerate and describe some GEOM classes I implemented. And the first one was probably the simplest one was gconcat. It is used for just concatenating GEOM providers. And you can concatenate any GEOM providers. There are no special GEOM providers. So in this example, I concatenate whole disk DA0, a slice DA1S1, and also a partition DA2S2D. So you can concatenate anything. You can even add a mirror here or encrypted provider here, whatever you like. This is your decision, and GEOM doesn't restrict your choice. I think the usage is very simple. You just use gconcat label, you choose name, which will appear here in the file system, and you just give a list of GEOM providers. Okay, we have gstripe, which is basically RAID 0 implementation. It also appears in /stripe under name we choose here. We can also stripe any GEOM providers, of course, but they should have equal sizes, because here we just stripe the data in this direction. Here we just have this AD0, we use sectors of this disk, and when we go to the end, we start from another provider and then we start from another one. This stripe we just use, those are basically blocks we stripe RAID 0 works in this direction. So when we write data, we use block 0, block 1, block 2, 3, 4, 5, etc. So it's really fast for sequential writes or even random writes, because in gconcat there are huge amount of data only provided by one disk. So when we write, we only use speed of one disk. When we use stripe, we can just use speed of all the disks we have. We have GEOM mirror, which basically provides simple, maybe not that simple, write one implementation. As in other examples, it appears in /mirror under the name we choose. It provides features like auto-synchronization, so when we have a power failure or system crash, it will detect that data may not be in sync, and it will try to synchronize our mirror. It also tries to avoid synchronization when it's not necessary. So, for example, if our disks are idle for like 5 seconds, it marks them as clean, and after a reboot or power failure, it just detects that there were no changes on the disk, so synchronization is not needed. So we can just avoid it. We can mirror any number of GEOM providers. In this example, we have 3 GEOM providers that are mirrored. It can also handle situations like disk errors or disk that disappears suddenly and stuff like that. Okay, we have GWrite free. Many people ask why I didn't implement it Write 5. There actually is Write 5 implementation, not by me. It's not in the tree yet. So basically, I somehow like Write free better because it gives better sequential write performance. What I most need, it's not that bad in random reads. Write 5 is actually better in random reads, but Write 3 isn't that bad either. The only restriction is that we have to have some number of providers because here we have sectors. For example, it's 512 bytes. So when we use 3 GEOM providers for our write-free device, sector size of this device will be 1 kilobyte, because in write-free, when we write, we have to write to the entire stripe. So we have to write, in this example, 1 kilobyte of data at least. This is all, basically used for only for parity. And because file system doesn't handle sector size that are not power of 2 and multiply of 512 bytes, we have a restriction of number of providers. We can't use 4 providers because it will give us kilobyte and a half of sector size, and the file systems basically can't handle that. So we have this restriction. We have to use power of 2 providers plus 1 for parity. Okay, we have GJournal. GJournal is basically provides basically block level journaling. It's not file system journaling. People easily confuse that because most of the time we just see file system journaling. GJournal is not file system journaling. Basically journals everything on the block level. It's mostly file system independent. File system still has to have a bit of knowledge about the journal, but the code is really simple which have to be implemented for each file system we want to support. But it can be used for file system for journaling file systems. Currently, it is only implemented for UFS on FreeBSD. And the usage is quite simple. We just create a journal provider, we create file system, and just mount it. You can mount it with async flag, which in this case is safe when we use journal. We can also use another GEOM provider only for the journal. So if you have a smaller disk but faster disk, for example, we can just split journal and data using those two disks. Okay, we have GEOM gate. This class allows to export storage over the network. I sometimes use it, it's really easy to use, and I sometimes use it for, I have some problems with my CD-ROM in my laptop, so I sometimes use CD-ROM from my home machine. You can just export ACD0 using GEOM gate daemon, and on my laptop I just attach GEOM gate provider. This is the name I have, and I can just mount CD-ROM I have in my home machine. You can export, of course, any GEOM provider and use it anywhere you want. It's not really something like NFS, because when you mount it read-write, you can only use it on one machine. Of course, if you have some synchronization software, you can use it on more machines, but basically you want to use it only on one machine when you open it for write. I don't know about end users of this GEOM class, but it was easy to implement, and I wanted to give an example. This implements shared secret functionality. So if you have 3 GEOM providers, you can, and you want to store some secret on them, you can use G-shared secret class to split the secret across all the providers. So if there is, if one of the providers is missing, we can read the data. Of course, we need, in this case, you only have space of one disk, but you can use it, for example, create small partition on your laptop disk and have USB key. You can create a GEOM shared secret provider on top of your small partition and USB key, and put file system on top of that. Once you remove USB key, you can't read any data from your partition. Okay, another GEOM class is glabel. It provides, you can choose names for your providers. They will appear in dev/label directory. Basically, if you have a situation like your disk names often changed when you switch the cables or stuff like that, you can use GEOM label to be sure that you always have name you can refer to. But also when you want to have nicer names, you can also use glabel. Glabel also supports many file systems. When you use, for example, UFS with -L option, you can label your file system, and this will appear in /dev/UFS/label of your file system. So it supports quite a lot of file systems. So you can just use labels that was assigned to them. The usage is quite simple. You just label your GEOM provider and use the new name. GLI class provides encryption and integrity verification. This is basically the class I'm most proud of. I spent probably the biggest amount. This basically took me quite a lot of time to do it right and implement all the features I wanted. And it's quite complete, and I think it's really useful. I use it on many places, and I know people use it also. Some features. Use crypto framework. So basically, once you connect any hardware accelerator, it will use it automatically. It supports various encryption algorithms. It also supports various authentication algorithms. So, for example, on your laptop, it's not only important to encrypt your data, but to be sure that no one changes them. And once you use authentication in GLI, you can be sure that no one modifies your data once you are away from your laptop, which is, I think, quite important. You can split your key over several components. You can, for example, give passphrase. You can read some random bits from a file or USB key or something like that. And you have to have all the components to actually be able to attach encrypted provider. You can even put your root file system on encrypted GLI provider, but you still have to have a small boot partition, probably on USB key or CD-ROM, to be able to load the kernel. Once you have the kernel loaded, you can mount a root file system from encrypted provider. Use KCS5 to make passphrase safer. It basically encrypts your passphrase given number of times using itself. So even weak passphrase can be quite hard to break, because to verify each passphrase, you have to do those additional steps to encrypt the passphrase using itself. So it's a really nice standard, and you probably should use it when you use GLI. You can use two independent keys to decrypt the GLI provider. So for example, if you are a security officer in your company, you can encrypt users' disks with their passwords and also with your own password. So if the user or employee forgets his passphrase, you can still decrypt its data and you can just start work again. GLI also use as many CPU cores as you have to speed up encryption, of course. And what I have in Perforce is suspend and resume support. This basically allows you not to detach provider, so you can still have /d/your disk.eli provider, but it removes all the keys from memory. So you don't have to unmount your file systems. For example, what I do now, when I suspend my laptop, I have to unmount my encrypted provider, and I have a lot of stuff on encrypted. So I have to go out from my directories that are on file system, on encrypted file system. I have to close my mail client. I have to close my web browser, stuff like that, to be able to unmount file system. With this functionality, I don't have to unmount file system anymore. I can still be sure that keys are cleared from memory, and on the resume I just give my passphrase and I'm ready to go. ZFS file system, which was ported from OpenSolaris, also use two GEOM classes. One GEOM class, which is on bottom of the ZFS, just connects to other GEOM providers. So when we give ZFS disks to use in our tool, we just use GEOM class to access to those disks. And when we use ZFS zballs, it is also a GEOM class which provides another GEOM providers. Okay. We have this GEOM utility which can be used to control most of the GEOM classes I implemented, and also it has some standard commands that can be used with any GEOM class. For example, we can use it that way. We just give GEOM class name and this standard command. Those two classes have no knowledge of GEOM utility, but we can still use it for some small amount of control. And we have GEOM classes that are aware of GEOM utility. Actually, quite a lot. You can control all those classes using GEOM utility. So this is one utility, and the class-specific functions are implemented using a shared library, which is stored on /GEOM directory. Okay, I will give you some tips. For example, as I said, GEOM doesn't allow you to open a disk which already have some file systems mounted on it, but you can work around it using this small hack. Just set the flags to 16 and you are able to open this, but be careful with it. Sometimes you have to do it because some tools are still not really GEOM aware. So, for example, when you if you want to add partition or slice, don't edit other partitions or slices, you are not able to open this to actually write new partition table. And this hack can be useful for that. Retest provider, you can use command like this. This is not smiley, it's just true. And you redirect the output to def name. Basically, once you open provider to writing, it will be automatically retasted by GEOM. It's somehow useful, for example, if you have a disk which is visible on two separate machines, and you edit the disk on one machine, and GEOM has no idea that the data was changed. For example, on one machine you create a partition table, but on the other machine you can't see those partitions. And to see them, you have to retest the GEOM provider, and you can use that command to do that. You can print entire GEOM tree in XML format using this syscontrol. And another important tip is that most GEOM classes store metadata in the last provider sector. If you know that, you can use various useful things, which I will try to show you in my examples. Okay, I will demonstrate basically a few things about GEOM and GEOM classes. I think we have time here. Can you see the phones? Type my password in front of you. Okay. Okay, so we have GEOM command. This is basically a hard link to other GEOM utilities. like gmirror, gconcat, concat, stripe. As you can see, this is the same inode, so this is just the same utility. It only discovers which class you want to operate on based on the name. So I can, for example, list GEOM label providers. I have a label for UFS root and for my swap partition. I can also list more information on for those providers. For example, I have name, I have size of the provider in bytes, I have sector size and access mode, and also some other class-specific data. And here you can use under consumers which provider it is used by to create this one. So VFS/root is based on AB0S1A. The same for swap partition. I will also attach my encrypted provider. As you can see, I have two encrypted providers, one for swap and one for my private data. I can also print some more information. Those are some GLI flags. This basically is one-time flag, which means that key is randomly generated on attach. It's quite useful for swap. You don't have to remember it after reboot. We also have vdetouch and vopen flags. Those are basically used for situation like when we open a provider for writing and we close it, it will be automatically detached and keys will be cleared from memory. So we can only open it once. For my private data, I also use authentication. Basically integrity verification. I use this algorithm to verify that no one touches my private partition. Okay. You can also, this is basically how we can use GEOM for other GEOM classes that are not aware of GEOM utility. But I can use it also for, this is basically the same command. If I use it this way or this way, it's basically the same. Okay, some examples. I will create two providers and, for example, concatenate them. Let's put file system on top of this concatenated device. I will put some random data. Now let's remember MD5 for this data. Okay. As I said, once you know that metadata is stored in the last provider sectors, you can, and GEOM utilities doesn't modify the data, you can just use some, do some useful things like, for example, expand the concatenated provider. I will stop it. We'll create another ND provider. And this will basically won't touch my data. So I can easily expand my concatenated device, and my data should be fine. I can now use GrowFS to expand my file system. I don't usually do that, but I have to lie here. I debug my data. As you can see, my provider now my file system now use more storage. Anyone remember 75?
Oh yeah, that's right.
Yeah.
Okay, but it works. You have to trust. Okay, another example. I will show you. We'll do it with Gmirror. As you can see, I have mirror on top of those two GEOM providers. I will also create file system for it. This is it. It's 10 megabytes, and as I said, GEOM utilities doesn't modify your data. So we can do something like this. You get a bigger disk. You can just clear Gmirror metadata. It won't touch your data, remember. And for example, we have bigger disk, this time 20 megabytes. You can just copy the data. Create mirror on top of new disks. File system is fine. You just we have the same amount of storage, of course, because we didn't use GrowFS. We have just expanded our mirror provider. So really, GEOM utilities doesn't touch the data. So you can do tricks like that, and can be sure that your data are safe, and it's really useful. Okay, I think we will go to questions. Are there any questions?
So, are there any things that package up a group of the GEOM classes that present them just as a single file system? So you can say, give me, if I give you a disk, you'll move back a encrypted, I've got these 3 classes, I don't know the classes that go with.
Only if you have script for that. Basically, GEOM classes are totally separated. But for example, there are things like stacked encrypted file system or block-level framework, stuff like that. So we can use, for example, free encryption algorithms, and you can encrypt your data using 3 different encryption algorithms. And I don't do that in GLI because with GEOM you can just simply create one GLI provider, then encrypt it with the same class but using different algorithm and stuff like that. But no, there is nothing like that. Yes.
What thought has been given to expanding GEOM to support some of the flash operations where you have to erase things in a group of 8K that you can access as a group of applicants? Like the memory device technology support that Linux has. So is there any work in that area, I guess?
I'm not sure. I think Paul is doing something with erasing the data. The infrastructure is in place actually. We have BioDB. We could just send on. Currently, it's not implemented, for example, in UFS to tell flash driver which blocks you don't use anymore. And this is basically what will be useful. To have such functionality in UFS. Then GEOM can handle it. You have to have support from file system to tell you which blocks doesn't want anymore.
Okay.
Are there any other questions? Okay, so thank you very much.